And now I work a great deal on social systems and how individuals, and it's a little hard to see in this slide, individuals compose a social body. It took me a long time, and again, this is something that struck me from the previous talk. It took me a long time for social scientists to tell me I was not, or that I was doing something other than just physics. And so I spent a lot of time convincing them that I had things to say about the social sciences. So what will you learn? You will learn some statistical physics, but at a very high level and a very qualitative level. You will learn some game theory on a somewhat deeper level. And I will begin with two critical concepts, I think, that we need to understand how society functions, the two sort of added ingredients that we have to bring in when we move from studying what we might call the natural world to understanding the cognitive world and the social world. So the first is the concept of other minds. Is anyone a reader of Henry James? Does anyone read? Oh, very good. Okay, so Henry James is an American novelist who spent a lot of time in England, and his novels are really deep examinations about not just what people think, but about what people think about what other people think. And sort of one level deeper, what people think about what other people think about what they think. Okay. So this kind of nested modeling, so I might, for example, think about this room, I might have some beliefs about the room, but I also have beliefs about you individually. I might, for example, believe that you can currently hear me, and that belief is the reason I keep talking in the way I am. If I suddenly believe something else about your own mental states, I would change my behavior. And in fact, I might not only believe that you can hear me, but I might believe that you believe something about me, for example, that I know what I'm talking about. Okay. So that kind of recursive modeling, okay, those kinds of accounts we build and things we infer about the contents of other minds, I will hopefully show you is a critical part of understanding social phenomena. The other part of the story that I'm going to introduce you to today is this idea of what we call in physics coarse graining. It's also called the renormalization group. So coarse graining is a way of producing a simplified and aggregate description of a system. Somehow, depending on what you're doing, you want to be able to throw out a huge amount of information and keep only sort of broad, approximate, but still useful categorizations. So to reference the past talk again, one thing you can think of is classifying people's political views, which are usually reasonably complicated. We all have some interesting thoughts about politics, but coarse graining them into a single number that tells you how far along the liberal conservative continuum you are. Okay? So throwing out a lot of the cognitive complexity that you have, okay, and instead working with some variable that describes in a very approximate sense what you believe. And in fact, that variable can be extremely useful. It might tell you, for example, how you will vote. It might tell you how good you feel about living in the state you actually live in. And of course, you can even go further and not just coarse grain an individual's beliefs, but coarse grain an entire society's beliefs. This is a tool that we have in physics. Coarse graining is a tool that we built. So for example, and this is just something that you learn if you're a physics student, right? This table is made of atoms, right? So there's an enormous complexity. There's an enormous amount of data you would need to specify everything about this table. But if I thump this table, I produce waves in the table. I produce, slight pressure waves. And in order to describe those waves, I don't actually have to describe all the microscopic detail, okay, of the individual particles. Okay? I can actually use something called the wave equation. And the wave equation coarse grains, it throws out a lot of the detail. And in fact, this table and this table, though they have totally different compositions, I can describe with roughly the same equation. And the fact that that works in physics gives us hope that it might work in the social sciences. And if it does work in the social sciences, what that means is we can talk about theories of society that aren't just complete descriptions of every single individual. We can talk about the mood of a society. We can talk about what a society believes. Okay? So, in the individualistic picture, we have actions. Okay? But in the coarse grain picture, we have what we might call group-level social facts. And I'll give you some explicit examples in a second. But the actions we take create those facts. And put another way, these social facts summarize our individual actions. And so one of the social facts that we'll talk about is prestige and power. Okay? The fact that one person in a room or one person in the corporation has power, okay, is a coarse-grained description of all the things that they may or may not be able to do. Okay? And that sort of coarse-grained fact about that individual, okay, is created by a large number of individual actions, not just the actions that individual takes, but of course the actions that other people around him or her take. Okay. Now, this is also true in the physical case, right? So I can produce an equation describing how this table will wiggle when I thump it, okay? And that summarizes lots of really complicated facts about the atoms in the table. But what becomes fascinating about social systems, okay, is that these group-level social facts come back and alter the mental states of individuals. So we, for example, might create a power structure, a hierarchy in our society, okay, that we summarize with certain social facts, but in fact we may actually come to know those social facts, okay? We become to be aware of the power in our society, okay? And in fact, not only that, but those beliefs that we have about those social facts may in fact drive our behavior, okay, and alter the social facts themselves. So we have a closed loop here where we create these what we call global variables out of local behaviors, okay? But we actually are interested, because we're people, we're intelligent agents, we're interested in these global social facts because we know, for example, they're very predictive, okay? So, for example, I might be interested in Stephen's politics, and I don't have, 3 hours to really talk deeply with him, so I'll try and figure out if he's liberal or conservative. I'll get a coarse-grained representation. Or I'm in Montreal, I want to know how to behave in a bar. Well, it's a pretty liberal city, right? Those kind of social facts are vital because they predict what's going to happen if I bring up certain topics, for example. But those, of course, will then alter my behavior, change what I do, okay, and feed back into the system as a whole. And this part here, which is unavailable in physical systems, right? Atoms don't really think about waves. They're just atoms. They only interact with each other, okay, on a microscopic scale, okay? This is where cognition enters, okay? This is where what it means to be intelligent changes the nature of the system, okay? So here's my top line. It's in order of increasing cognitive sophistication. So I will begin with undergraduates, and I will show you that undergraduates are aware of social facts, okay? Then I will go to some recent research with a fantastic collaborator of mine, Elizabeth Hobson, on parakeets. And not only will I show you that parakeets are aware of social facts, but actually they choose to act upon those social facts. Okay. And finally, okay, at the top, so we don't really get that high in terms of cognitive sophistication, finally I will go to Wikipedia users. Okay? And I will talk about how you might construct a theory of society that doesn't directly reduce to just talking about the individual mental states of the people who participate. Okay? So undergraduates, parakeets, Wikipedia users. So, the social fact we'll talk about in this first part of the talk is prestige. So one of the people I often read, and my wife is a political theorist, so she actually reads this man deeply, is Niccolò Machiavelli. And Machiavelli was aware of the fact, Machiavelli was somebody who came out of the aristocratic tradition. He realized democracy was coming, and so one of the things he realized was that we should probably have some good theories about what ordinary people believe. Okay? We should probably start trying to figure out how people actually form beliefs in their society and what those beliefs did. And so one of the things he talked about was prestige. And prestige is different, okay, from physical power. It's also true, in fact, in animal societies. Okay? Animals may have social power even when they're not larger or stronger than other animals. Here, this is a case he has. This is from one of his early writings where he talks about how the King of France increased his military power by hiring Swiss mercenaries, okay? But this actually had the negative effect of destroying the social fact of his own prestige, okay? Here's another example where he talks about how prestige is a consensus-based quantity. People need to agree and to see that each other agree, okay, on the extent to which someone does or does not possess prestige. And finally, this sort of strangely sort of snake eating its own tail nature of prestige, right? He says, weighty men who have prestige will always occupy the highest places, right? So what makes them weighty men? Well, somehow it's the fact that they have prestige, okay? And the fact that they have prestige means they occupy high places, which of course means that they are weighty. Okay? So prestige has a kind of nested social recursive nature, right? For somebody to have prestige, it means, well, first of all, it means people think you're good. But not only that, you have to have the right people think you are good, right? So it's not just that people think you are good, it's that people who people think you are good think you are good, okay? And people who are thought to be good by people think are good, think you are good, right? What matters, for example, and this is a classic example in the case of how academia works, right? If Stephen thinks I'm smart, the fact that he thinks I'm smart is not quite as important as the fact that everyone thinks that he is smart. And so that recommendation, that level of trust, okay, means that his opinion is worth more than somebody else's opinion. For my mother thinks I'm very smart, but that doesn't affect my prestige as much, okay, as a mild opinion expressed by somebody who has a lot more prestige. Okay. So, I didn't want to grade the midterm presentations in my class that I taught last semester. I actually did grade them in the end, but I was very curious about the following thing. So all of my students did group projects, and what they did was they presented them in a sort of short 10-minute show. Okay, and we had one graduate group, and we had 5 undergraduate groups. And what I asked them to do was just rate each other, rate their presentations, and so they could circle, a number between 10 and 1, and this person here, had very kind of fine-grained distinctions, right? So the graduate students got a 9.5, and one of the undergraduates got a 9.25. Okay, and so what I had them do is essentially express a belief about how good the other presentations were, and I actually asked them also to rate their own presentation and to just tell me, draw a little star next to, their topic. So I didn't keep their names. What I did keep, was which presentation they were involved in and the ratings they gave of themselves and others. And then just to be clear, I have protected their privacy because I moved this star from the position it was in. Okay. So what I'm going to do is I'm going to interpret these ratings. I have to make a little map. I'm going to interpret these ratings, as an action. And what I'm going to do is make that action dyadic. So the actions, involve a relationship between two people, in this case between the rater and the person rated. So what I'm going to understand the giving of prestige as a dyadic pairwise interaction as opposed to, for example, a triple. And what I'm going to do is I'm going to imagine, and this is sort of a simple way to think of it, I'm going to imagine that I have a little trophy to give, and I'm going to choose probabilistically who to give that trophy to. And the chance of me giving the trophy to somebody is directly proportional to the rating that I give them on the sheet. And that's not the only way to do it. For example, I could say I always give the trophy to the person I think had the highest rating. But I somehow have to map beliefs to an action, and I'm going to interpret that action, now as the giving of prestige from one person to another. And note, of course, you can actually choose to keep the trophy, because you did also rate yourself, and if you rated yourself particularly highly, then there's some non-zero probability that you'll actually keep the trophy in that round. But then you try again the next round, and maybe you give it away. So I want you to imagine all the undergraduates, sitting in this classroom, mentally awarding each other trophies and passing that trophy around. And imagine them doing that for a long time. And then you walk into the room and you say, who has the trophy? Some people are going to have the trophy more often because they're highly rated by other groups. Some people are going to have the trophy not only because they're highly rated by other groups, but because they're highly rated by people who themselves often have the trophy to give away. So by walking into the room and asking who has the trophy, I now have a measure of prestige that incorporates not just being liked by others, but being liked by others who themselves are liked. And so on recursively down the line. Here's the distribution of prestige, academic prestige in my classroom. So there are high-power groups, who tend to be found with a trophy more often. In fact, the highest rated group, or rather the highest power group, was not necessarily the highest rated group. The highest power group, gets the trophy about 20% of the time compared, to getting the trophy about 1/6 of the time if everybody in the group had equal power. So what we're measuring here is a distributed social fact. It's a very simple social fact, right? But what we've done is we've aggregated 36 beliefs, right? The beliefs that each of the 6 groups has about themselves and all the other 6 groups. We've taken those 36 beliefs and coarse-grained them down to 6 beliefs, Beliefs about the relative power, and in fact, we can actually not just say who has more power or who has more prestige than somebody else, But also we can quantify that. So we can say these 2 groups here, for example, have nearly equal power, Whereas these 2 groups here have actually quite distinct levels of prestige. So I've summarized those beliefs in terms of 6, but those 6 don't directly reduce down to the beliefs of any particular individual in the group. These are high-level descriptions of the system. And what's interesting was that these beliefs, what we call in this graph here community praise, the beliefs the group has about how good each of the presentations were, actually correlates remarkably well with how the groups estimate themselves. Okay? So what I plotted here is the chance that when this trophy is being passed around in your grand social scheme, right, this is the chance that the trophy will end up in one of these groups. And here is the probability that the group will keep their trophy that round. Okay? So this is a direct comparison between the individual beliefs of the group, okay, and the beliefs of the class as a whole. And in fact, they're strongly correlated. So the people who think they have low power, in fact, do have low power. The people who think they're actually really good, they turn out actually to be believed by the rest of the group to be really good. So there's a couple things. This is the straight axis, right? So everybody thinks they're slightly better than the group thinks they are, except this node up here, okay? And those are actually the graduate students. And I can't tell if it's because they're graduate students or because they're not all Americans. Okay, but everyone else rated themselves. Okay, they basically thought they were slightly better, but in fact, only in one case do you have an inversion here. These two groups slightly disagreed. Okay, about what order they were. Right, everybody else tended to get it right. Okay, and in fact, this holds. So one of the things that you might worry about here is that the community praise includes the beliefs, okay, of the groups themselves, right? So the rating that I give to myself influences slightly the group level belief. But you can actually redo the whole analysis and say, take out, forbid self ratings, that you always have to give the trophy away. You can never actually say that you get to keep it that round. And in fact, the same correlation persists, right? So individuals, or rather groups in this case, right, the little teams that work together to produce these presentations, are aware of the high-level social facts. So, we can talk about these distributed beliefs. We can aggregate social variables, not just for human systems, but for animal systems. And in fact, a lot of our talk about dominance and hierarchy and rank come out of the animal literature, right? So alpha male, right? Okay, the alpha dog in the system. It's obviously the kind of coarse-grained popular version of hierarchy is wrong. It turns out there are many competing hierarchies in any animal system. They change on different timescales, right? But what people often like to talk about is given a particular kind of interaction, okay, and given a particular time scale over which you average, okay, can you extract some kind of relative rank of individuals? Can you say who's on top, who has more power, and who has less power? Okay. In the case of the undergraduates, we talked about people giving praise to each other. Okay. Here we're going to talk about birds aggressing against each other. So this is a shot, this is a slide from Elizabeth's work. So here's a bunch of parakeets on a branch, and they peck each other all the time, it turns out. Okay. And so here is the aggressor, and then 2 birds away, okay, is the target. And these are people just watching. Okay. And then within about a second, the aggressor reaches over and just pecks his branch mate off the branch, and for reasons that to me are entirely unclear, okay? But basically displaces this individual, forces them to fly away and go somewhere else. And so now what we have, okay, is a very rapid timescale interaction that says you are less than me, or at least that's how we're going to interpret it. Just as we previously had to sort of work from the ratings that students give each other, okay, and map that to a theory of beliefs about relative power. Here we're going to map the giving of aggression, who you choose to insult, who you choose to aggress against, okay, and use that to measure social prestige in the animal group. And what you find is fascinating, okay, because not only can you detect a dominance hierarchy, but you can also detect evidence that the birds themselves are aware of the dominance hierarchy. So what I've plotted here, okay, on the x-axis is rank difference. So we're going to ask, how do birds behave against other birds in the system? Okay. And in particular, how do birds behave towards those who are lower ranked, who have lower social power, versus those who are higher ranked? And what you find is that the average aggression, the number of pecks per day a bird directs towards somebody lower in the hierarchy is higher than the number of pecks they direct towards somebody above them in the hierarchy, which is not surprising. And the reason that's not surprising is, of course, the dominance hierarchy is itself constructed out of who you choose to peck. Okay. But what's fascinating is that compared to the null model, compared to unstructured behavior that preserves the power structure, birds, in fact, focus their aggression Okay? They spend very little time aggressing against people far below them in the hierarchy. In fact, what they do is they spend most of their time obsessing about the people just a few ranks below them. Okay? This might be familiar to you, right? The football team doesn't beat up the chess nerds necessarily. They beat up the lacrosse team, right? They beat up people who are slightly lower, or in some cases, and we call these rank entrepreneurs, people who are slightly above them in the hierarchy. Okay? So the birds themselves are aware of these social facts. Okay? In fact, not only that, but Elizabeth, this is amazing because I think this is just great. And we're going to do this on the Wikipedia users too, but we haven't done it yet. So when Elizabeth started taking this data, which is enormously hard to gather, right? So she has to keep track of all these interactions, right? But she actually started her PhD when they released all the birds into the pen all at once. So these birds had never seen each other before. Okay? And in the first week of their interactions, there was no social signal for them to work. In fact, yes, they're pecking each other, okay? But they're not strategically focusing their aggression, okay? In the first week of data, and she actually had two groups, so we get a replication here. So these are two independent groups in two separate pens, okay? What you find is, yes, that birds peck downwards in the hierarchy, which again, just to be clear, is not a surprise, because that's how we construct the hierarchy, okay? But they seem to show no discrimination between pecking people far below and pecking people nearby. But after about a week, okay, the signal where birds tend to aggress anywhere between somebody just below them and 20 ranks below them, okay, disappears, and all of a sudden these birds are now focusing their aggression in a really narrow band. The people, or the animals, that are very closely related to them in rank. Birds that are potentially, okay, rank competitors with them. Okay, and in fact, quarter 2, quarter 3, and quarter 4 all show this effect. So what you see here at the early stages is that while the birds are indeed acting and creating a dominance hierarchy, they're not aware of it. Okay, their behavior is not structured. Okay, but after about a week, they become aware, and so now their behavior clearly distinguishes between people who have low and high power. So then the next question is, how do they know this, right? So if you know page rank, you know this kind of analysis. Right? This is finding the stationary distribution of a Markov chain. So as Elizabeth and I love to point out, right, birds can't diagonalize matrices. Okay? So how do they come to know the social fact? What we're showing here, right, in order to make these graphs, right, I have to do this whole analysis, right, where I take the matrix and I diagonalize it and I find the eigenvalue, right? I find the lambda equals 1 eigenvalue, right? Birds obviously can't do that. They have to rely on some kind of social cue, some set of facts about the world that are cognitively relevant to them. Okay. And what are those facts? And so they're clearly able to do it. They're able to structure their behavior with respect to rank. Okay? But how? So what we thought was that they would do the following kind of reasoning. What they would say is that I might peck somebody, that's sure. I don't know why I do it. I just have this urge to peck somebody. Okay. Maybe you have this urge too, right? Okay. But the people I peck themselves have an urge. Okay. And in fact, I might reason that if I peck somebody and they themselves peck somebody, this person down here is lower ranked than me. Okay. And in fact, these chains, which they can perceive, all it requires them to remember are who they aggressed against and who those people aggressed against. Those kinds of chains, those linear chains, graph motifs, okay, actually contain a great deal of information. Okay. And in fact, you can discriminate a wide range of ranks between somebody 5 ranks below you and somebody almost 15 ranks below you, so a range of about 10 ranks. Okay. You can discriminate between individuals solely based on those little graph motifs. Okay. It's not perfect. You're not going to get perfect rank information, but there's a lot of information there. And to be clear, that kind of signal is absent when the behavior itself is not structured. Okay. So the birds not only use the signal, but in acting, create the signal. Okay. And just to complete the square, right? So what we've shown is that, okay, birds have some knowledge of social facts. Okay. We've shown a cognitively plausible way that they could come to know those social facts. And now we have to show that they act on those social facts. Okay. And so this is the final thing here. So this is, say you see somebody, okay, who's a long way from you in a chain of aggression. Okay? So, Rob beats up me and I beat up Peter, right? Peter beats up Stephen. Okay? So now you've seen Stephen, okay, at the end of a long chain that began with me. Okay? How much do I either increase or reduce my aggression against the end of that chain? Okay? And in fact, it's clear that the more steps separate you from that person, the less likely you are to regress against them. And in fact, you reduce, okay, you over-aggress against people who are near you in chains, and under-aggress, you significantly reduce by almost 50 percentage points, okay, your aggression against people who are at the end of one of these long chains. Okay? So what we have so far, we have this part of the story, okay, which is the statistical physics side. So what we do is we summarize facts about individual interactions between birds or undergraduates. We summarize them into these larger social facts. Okay? In the case of the undergraduates, I gave you reasonable evidence that they themselves reveal that they know something about what the group thinks, about the group level social facts. So we can show that individuals know these social facts. And then finally, in the case of the parakeets, we can show that that knowledge of social facts influences behavior in a cognitively plausible manner. If birds rely upon these motifs to structure their behavior, okay, we can explain not only how they come to know who has more power than them and who has less power than them, but we can also explain the actions they take. Okay. So, questions? Parakeets, undergraduates? Okay. So, this story about social facts is one that we'll come back to at the end. And let me draw a line between the question of knowing what other people think about you, okay, and the kind of strategic reasoning that we were taught to do when we learned game theory. So this is a photograph, an early photograph of, does anyone know? John Nash. John Nash, yes. Okay. So the idea of social prestige and social power is recursive, at least in the way we're analyzing it. It depends entirely, okay, upon what other people think about you and what they think about what other people think about you. Okay. But in fact, John Nash presented a theory of human behavior, okay, that was sort of recursive at the core. And so this is really hard for me to say. I'm not Henry James, so I say it as elegantly as this. Okay. So the idea of game theory and the idea of what was called the Nash Equilibrium, okay, requires only that you have a theory of what's called the best response. Okay. So you have some social situation that you imagine happening, and you say, what is my best response to that situation? Okay. And so what I do, which is a list of probabilities of different actions, and so this is the way we'll quantify social behavior. Okay. The probability of taking action A or B or C. Right. What I do is a best response to what I think you will do. Okay. But of course, what you do should be a best response to what you think I will do. But of course, what I will do depends upon what I think you will do. Okay. And so mathematically, you say, my actions are the best response, okay, to your best response to my action. Okay. And this is called the Nash Equilibrium. This is a very sort of high-level story about a Nash Equilibrium. And so one of the questions you have is, can you actually solve this equation, right? Because just because I put something on the left-hand side and something on the right-hand side doesn't mean I can necessarily solve it, right? So x squared equals -1 does not have a good solution on the real numbers, right? But it turns out, in fact, you can always solve this equation. That goes back to something called the Brouwer fixed point theorem. Does anybody, I actually didn't bring paper. Can anyone give me 2 sheets of paper that they can give me forever? Big or small, it's okay. Thank you so much. So imagine that this sheet of paper here, okay, at each point here corresponds to a set of actions I might take. Okay? So for example, if you want to be very literal, and this can be helpful, right? Imagine that I have 3 probabilities. Okay, I have a trace between actions A, B, and C, and on this axis here is the probability of A, and this axis here is the probability of B. Right? Okay. So I map this point, and in fact any point on this page, to a new action by using the best response to the best response function. And the question is there some point, okay, on this piece of paper that remains unchanged when I go through that map. So what's called the Brouwer fixed point theorem tells you, in fact, that there is at least one point where this is always true for any function whatsoever. So for any social situation, and this is how Nash interprets it, for any social situation, okay, you can find an action such that it induces everybody else to do something such that the action you took is the best response to what you induced everybody else to do. And so practically what that means is that any function whatsoever, so for example, this function is the identity, that's easy. Okay? This function is the rotation, right? And so one point here is fixed, right? Okay? This function is, the rotation, and then the inversion, and then like that. That's another function, right? But in fact, any function, so in fact, when I scrunched up this piece of paper, there was in fact one point here that didn't move, okay, from where it began. So that's the Brouwer fixed point theorem. And so that was what Nash leveraged to say, in fact, that you could always produce a theory of what people would do. Okay? So here's a very simple example. The prisoner's dilemma. Are there any physicists in the room? Good, right? So right, my colleagues, right? The prisoner's dilemma is like the simple harmonic oscillator for social systems, right? It's the simplest possible story where something interesting happens. So does anyone not know the prisoner's dilemma? Raise your hand. You're not on video.
You have to say, no matter what they say, you have to state the prisoner's dilemma.
I have to state the prisoner's dilemma.
Because there will be people who will say that they know it, but they don't.
Okay, got it. Okay. Okay, so the prisoner's dilemma, there are two players, okay? And they are, in fact, two criminals, and they're caught by the police, and they're taken to separate rooms. They've committed the crime together, taken to separate rooms. And the police know, it's a sort of a law and order scenario, the police know that they don't have enough evidence, okay, to convict either one of them. But if one of them turns state, so if one of them gives the evidence to the police, they can get both of them. And so what they do is they go and talk to each prisoner in turn, okay, separately in separate rooms, and they say, look, if you tell us how you did this, we'll let you off, okay, and we'll use the evidence to get your friend, but don't worry about him, because he'll be in jail forever. Okay. Now, if neither of them talks, then maybe they get, done for trespassing, right? Okay. If one of them talks, okay, if one of them defects, as the phrase goes. If one of them defects, that person who defected gets a huge payoff because he gets to walk free, and his friend gets what's called the sucker's payoff of having to be in jail for 30 years. Okay. If they both defect, okay, then they're both in trouble. Okay? And you can turn the knobs on these different numbers here. Let me just show you how to read these diagrams. Right? So here's player 1 and here's player 2. Here are the actions they can take. Okay? So in this term in the matrix here, okay, if both cooperate, player 1 gets payoff C, which is a positive number, and player 2 gets payoff C. Okay? So let's imagine, or let's work through the best response story, okay, on this plot. So let's say, for example, I think that you're going to cooperate. So I'm player 1 and you're player 2. So I think you're going to cooperate. What's my best response? Okay. Well, in fact, I can get a payoff C if I cooperate with you. But I can do even better if I rat you out. Okay, I get a payoff W, the winner's payoff. Okay. So if you cooperate, my best response is to defect. Okay. But that turns out not to be a fixed point. Okay? Because the other player's best response to your defection, well, let's take a look. Okay? He can either cooperate, in which case he gets payoff S, which is negative. The sucker's payoff is negative. Okay? Or he can defect against you, okay, and get a payoff 0, so he gets sort of the neutral payoff. Okay? So his best response, okay, to your defection is not to cooperate. And in fact, the obvious answer in this case is a very simple game to analyze because there's a strong domination, okay, is that both players defecting is the Nash equilibrium. If I know that you're going to defect, my best response is defect against you. And if I defect against you, your best response is defect. Okay? So the function defect maps back to defect, and we have our fixed point. That's the Nash equilibrium.
Okay. You're at 1/2 hour out of 45 minutes, and you have not mentioned the word Wikipedia once. I just want to point
that out.
So, Prisoner's Dilemma is a game that models almost nothing in the real world. It's a fascinating game. It's a great story. Okay? But what I'd like you to do now, I'll walk you through what a Nash equilibrium is. Okay? I'm going to tell you how to solve a much harder game theoretic problem. Okay? And that game theoretic problem is how people cooperate on Wikipedia. So this is a group that I don't really have to pitch Wikipedia to. There was a very interesting paper that was in the website conference that mentioned that, in fact, we've now had 13 years of Wikipedia and 12 years of scholarly articles and scholarly research on Wikipedia. So this is an amazing system. One day we will all have the right to our own data, but right now we don't. So Wikipedia is a social system involving on the order of 100,000 people. It's been running for over 10 years. Okay? We can track millions of actions, and they're tagged right down to the second. Okay? So we can watch a society construct itself from nothing in 10 years. Okay? A society larger than the town I used to live in. Okay? And we can do so over 6 orders of magnitude in time scale. So we can watch how users interact second by second, but those users persist, in many cases, over many years, and the culture that they all contribute to has persisted for a decade. Okay? So this is a remarkable sort of test case, okay, for large-scale quantitative analysis of social behavior. This is a comparison I'd like to do. Again, I have a feeling I'm in a crowd that understands the web very well. This is the list of board members on the Encyclopedia Britannica. This is a list of the top editors on Wikipedia, and it's fun just to compare them. It's fun to compare 2 theories, okay, of how we should build encyclopedic knowledge, right? So, you know, on the left-hand side, Murray Gell-Mann, who used to be at the Santa Fe Institute, where I spent 4 years. Nicholas Carr, who also happened to write a book called The Shallows, How Wikipedia is Ruining the World. Thomas Nagel, Amartya Sen, right? Great intellects, okay? Compared to what we all know are internet users, okay? So slightly above parakeets, okay, in terms of social sophistication. Okay. And so the problem is, the question is, how do we explain the success of a social system that doesn't have the kinds of top-down control that we usually associate with, in this case, large-scale productions of knowledge? Okay. So the most edited page on the encyclopedia, does anyone want to guess? Maybe you've seen this. What is the most edited page on Wikipedia? Scientology, it's in the top 40, certainly. Abortion, also high. United States is high, Jesus is high, but the top one is George Bush. Okay, and so one thing Wikipedia is preoccupied with is, yes, the production of knowledge, but also the arguing about controversial topics. Okay. And, you know, what I use Wikipedia for is, you know, I can't remember the Brouwer fixed point theorem, and there's, you know, a bunch of nerds that have written this up for me on the encyclopedia, okay? But where all of the social action is in producing an article like this, and I encourage you to look at these articles, okay? Look at the George Bush article, because what's amazing about it is that it's so boring, okay? Right? This is an article that looks as if it was written by college students from Mars that had no emotional or moral or political investment in the topic. Okay, so how is that possible? Right? It's weird. The guy does. It's like you're sort of puzzled as to why he would be important. Right? There's no passion whatsoever. Okay, everything is completely balanced between. And I don't need to tell you that George Bush is one of perhaps the most polarizing figures. Okay, so looking under the hood of Wikipedia is where all the action is, because you look at how people actually come to an agreement on the content of the page. And again, you should probably know this, but if you don't, there's really no way for you to fix a final version of Wikipedia. You can't kick other people off. It's very hard to kick other people off. I'll tell you a little story about how someone got kicked off. It takes a long time. We work on, in a separate project, we work on the British criminal justice system. It takes more words to kick someone off Wikipedia than it does to execute them in the 19th century in Britain. Okay? It's easier to hang somebody than get them off the encyclopedia. So in order for you, okay, to contribute to the encyclopedia and for your contribution to stick, you have to get agreement from a wide variety of people. Okay, so this is just a little, and this just shows you example of how finely we can track the kinds of interactions that people have with each other, right? So at 8:10 p.m. Universal Coordinated Time on the 13th of February 2011, chosen at random, okay, Ashiva 2010 puts something into the encyclopedia, and in fact he leaves a little comment. This is the history page of the George Bush article. He has a little comment. He says, this is a reliable source which needs to be displayed. If anyone thinks the Guardian is a biased source, or if you are a conservative and would like to object to this, please comment on my talk page. Okay, so not somebody who's good at conflict resolution, right? And in fact, 20 minutes later, the user Fat and Happy comes along, and he actually makes another edit on the page 20 minutes later. And in fact, what he does was take out the entire contribution, okay, that the user Ashiva 2010 put in, right? So he just does what's called a revert and undoes the work of Ashiva 2010. Okay. 3 minutes after that, Ashiva 2010 comes back. Okay, and he actually puts something else in, okay, and he actually says he reverted the previous edit that deleted the following site. I'm not quite sure what that means. And then 7 minutes after that, he himself was again reverted by a third user, Sox1. So this is the sort of under-the-hood story of how people try to put content in the encyclopedia, get it taken out, okay, propose new content, have that taken out, and essentially argue back and forth about what the representation of George Bush should be on the Wikipedia page. So what we found here, we are unable to read all, 45,000. It was 44 when I started. It's now 45,000 edits on the George Bush page. We can't actually read all of those, so we have to automatically identify them. And what we focus on is, in fact, this revert behavior. So the revert behavior is you can make an edit on the encyclopedia, and all it does is completely undo the work of somebody who came before you. Okay, so you can just hit the undo button. Okay, and reverts are something that, in fact, in the system itself are understood as kind of a bright line, like you shouldn't do this. There's a social norm against reverting each other. Okay? And not only is it a bright line within the culture of the encyclopedia itself, but in fact, psychologists have gone in and studied that what we call task conflict, okay, so debating about whether or not, okay, this particular set of text should or should not appear in the article. So task conflict, as measured by reverts on a wiki, task conflict correlates 80% with relationship conflict. Okay, and so the way you should think of a revert is, you're working with your advisor, okay, and he sends you a new draft of your article, and you take out all his edits and send it back. So clearly, you at that point are in conflict with your advisor, and so that's what we're able to track here. We're able to track just as in the case of the birds, we track the pecking. Here we track some action that strongly correlates, okay, with conflict. But now what that means is we can take this very complicated debate here. So this is a question of whether we should mention that George Bush was the first Republican president to appoint a black Supreme Court justice. Like, should we put that in or not, right? We coarse grain, we summarize all those interactions into a binary choice. The choice is, do you contribute, do you cooperate with the norms of the encyclopedia and add new content or modify the page in such a way that you're not simply reverting it, okay? Or do you revert, okay? And so this is the behavioral time stream. And so now every edit in the encyclopedia and on a particular page, so this is actually the data from the George Bush page, right? So there's 45,000 symbols here. Every edit is now characterized as a C or an R. Okay. And so in fact, by the way, right, the third edit on the George Bush page was a revert, okay? So it took 3 edits for somebody to get angry about something that was said about George Bush and undo it. Right? Okay. So we're going to produce a model, game theoretic model of this behavior. And so the first idea that we can think of is modeling this as a prisoner's dilemma. So I have a choice. When faced with the task of editing the encyclopedia, I can do one of 2 things. I can cooperate with the norms of the encyclopedia and edit normally. Okay? Or I can defect or revert. And reverting here means undoing the work of somebody else and thereby gaining some kind of social advantage, right? Gaining control over the debate by saying, no, I'm taking that all out, and we're going to do it my way. Okay. So there's one difference with Wikipedia compared to the standard prisoner's dilemma, which is that the moves in the standard prisoner's dilemma are simultaneous. You're in separate rooms and you can't see each other. But Wikipedia is completely transparent. Okay? And so in fact, what you have is a stage game. You come along, okay, to the page, having seen what everybody else has done so far, and you have a choice now. Okay? Do you add new content, or do you revert the previous editor's action? So here what I've assumed is that the previous editor came along and cooperated with the social norm. They added new content in some way or another. Okay. So now you have a choice. Do you participate in the encyclopedia or do you revert? Do you undo that person's action? And depending on the choices you make, okay, you will change the social context for the next editor. Okay. So you can choose to either cooperate or defect against the previous user, and the next editor has a similar choice for you. So in this case here, you cooperated with somebody who cooperated, and the next editor comes along and similarly cooperates. So you get a certain payoff. Okay. But all four of these options give you different structures. Okay. So what matters when you come to make your choice is what you believe will happen next. You know what the person before you has done. Okay. But you don't know what the person after you will do. Okay. So you hold some belief about what will happen. Okay. And in particular, we're going to simplify the story, and we're going to say that you believe only one of two things, or rather, you only have two beliefs. 5 minutes. Thank you, Stephen. You believe only one of two things. Okay. You believe that the person will revert you with some probability beta, okay, given that you cooperated, or revert you with some probability beta given that you reverted or defected. Okay. And in fact, now you actually know what to do. You will cooperate after cooperation if your expected gains from cooperating are greater than your expected gains from defecting. Okay. But there's a problem here. Okay. And the problem is that this is a deterministic equation. If this side is greater than this side, we already know what you will do. Okay. And so, depending upon your beliefs about society, you will always do the same thing. Okay. So the encyclopedia under the standard model, okay, will be either pure cooperation or pure defection. So we add stochasticity to this game. We add stochasticity through a failure to have precise knowledge about others. And in fact, it turns out there are two kinds of ways to add uncertainty. Okay? In the standard game theory formulation, we add uncertainty, okay, by thinking about imperfect versus perfect information. And so the classic example is in poker. I know the rules of poker. I know when you win or lose, but what I don't know, okay, what I don't know is whether or not you have, let's say, a full house or a pair or nothing at all. Okay. We're actually going to use a different kind of uncertainty. This is the standard one. Okay. We're going to use a different kind of uncertainty, which is the distinction between complete versus incomplete, okay, information. And when I have incomplete information, I don't actually know what the rules of the game are. Okay. So it's like Calvin ball. Right? I don't actually know what the other people value in the game. I don't know what they think of as winning the game of Wikipedia. Okay? So it's this kind of uncertainty that we will give to the participants in the system. Not this one here where I don't know the cards you're holding, but this one here where I don't even know what game you're playing. Okay? I think I'm playing the prisoner's dilemma, but in fact, you might be playing a very different kind of game. Okay? And in fact, what I can do is I can parameterize this and move you from perceiving Wikipedia as a prisoner's dilemma problem to a problem of mutualism. Okay? And so let me just give you two examples, okay, of different kinds of users that you can detect in the system. Those who perceive the problem as one of gaining the advantage through a revert, and those who perceive their advantage as coming purely from cooperation. So this is actually my old college roommate, Nils, who I found is also a Wikipedia editor. Right? So Nils is somebody, okay, Nils is somebody who loves to cooperate and encourages other people to cooperate and says, I won't revert you, don't worry. Okay? So this is the kind of person whose payoff is very different from the prisoner's dilemma payoff. Okay. And there are other users, and this is a user very verily who I don't know much about, but he actually comes up in our machine learning algorithms a lot. He is somebody who has a great deal of trouble cooperating and appears to value the game of Wikipedia as if it were a prisoner's dilemma. Okay. So I won't go through how we actually solve this problem. You can see it in our paper, which just came out on the archive. Okay? But what we're parameterizing is the extent to which, and these are sort of two opposed views of the origin of social cooperation, the extent to which you view the problem of altruism, foregoing benefits that you could get by defecting, versus mutualism, where in fact we can both gain by behaving well. So I will not solve this equation because I'm running out of time and I want to have time for questions. So I will tell you, it's really great, and this is the physics side of me coming out. Okay. So what I will tell you is that depending upon the structure of the system, depending on how uncertain I am about the composition of my social world, okay, I have a probability for reverting. Okay? Behavior becomes probabilistic depending upon the heterogeneity of the system. Okay? If I knew everybody was mutualistic, okay, and I myself was mutualistic, then Wikipedia would be a game where everybody just cooperated all the time. There would be no arguments. Okay? If the game was a prisoner's dilemma game, okay, and I also thought it was a prisoner's dilemma game, then we would all revert each other all the time. We would have no way to actually contribute anything because people would always gain the advantage on each other. They would always have the temptation to defect. They would always have the temptation when they encountered somebody they disagreed with, not to compromise, but rather to undo and to revert. Okay. But if I'm uncertain about who I will encounter next, and if others are reciprocally uncertain about me, now all of a sudden we have a game that can drift. People can play different strategies over time. And in fact, we can summarize these strategies in the following way. This is a phenomenological regularity came out as a paper in PLOS One last year. Okay? But what we detected, okay, was that what governed people's propensity to revert, what altered people's decisions whether or not to cooperate with the social norm, okay, depended upon how much cooperation they had seen in the system so far. Okay. So what that means, and so this is the example here, if cooperation was independent, if there was no belief change over time, okay, then what you would expect to see is an exponential distribution of cooperative streaks where people fail to actually argue, they actually get along. But in fact, what you find, and this gets back to the talk we had this morning, in fact what you find is the cooperation is extremely bursty. Okay? Once it gets going, it's actually easier to keep going. Okay? And what we understand from the game theoretic models, okay, is how that relates to people's beliefs about the system itself. Okay? Their beliefs about the game that they're playing and the game that they think other people are playing. And so now, in order to explain this burstiness, we have to explain how people's beliefs change. We have to explain how they come to believe that other people are actually more likely to cooperate, that if they actually try to contribute something positive to the encyclopedia, it won't get immediately taken out by somebody who disagrees with them. So their beliefs are changing over time, and what we can do is track that as this bursty phenomenon, okay? And in fact, it turns out that in this case, it's not a Streck's exponential, it's a power law, okay? That the probability of the norm violating action declines as the square root of the number of cooperative steps. Okay? So very quickly, once you have a few cooperative edits in the encyclopedia, once you perceive on a particular page people editing as opposed to reverting and undoing, once you perceive that, it actually makes it easier to avoid conflict in the future, but those gains actually begin to asymptote. Okay? So going from 1 cooperative edit to 10 cooperative edits is great. It's about a factor of 3. It's 3 times less likely to have a revert if you've been able to get 10 edits in a row. Okay? But after 100 edits, you've only gone down by another factor of 3. Okay? So there are returns to scale, but they diminish over time. Okay? So what I'd like to say to you is what we have here is a coarse-grained representation of a complex interaction. So what we've talked about is how people's beliefs change about the system. They start to understand, or they start to believe, or they behave as if they believe that the people they're encountering are mutualistic performers as opposed to people who see themselves as in a prisoner's dilemma where they're trying to get the most for themselves and are afraid of others doing the same. But of course, individuals have far more complexity to what they do, right? The ways that people interact, okay, the ways that people talk to each other on the encyclopedia are incredibly complex. Okay, ethnographies have now been written, many ethnographies have been written about exactly how people come to make these decisions. Okay. What we're able to do is we're able to describe that by a single social variable that scales in a particularly simple way. What we have in some sense is a wave equation, okay, for cooperation on the encyclopedia. Okay. It turns out that that cognitive complexity washes out if what you care about are these large-scale problems. And of course, if we reference back to the parakeets and to the undergraduates, presumably, even though individuals understand themselves as having complex social relationships, they're also able to understand the influence, okay, of this epsilon parameter that tells you how much the group as a whole tends to behave. So let me just put up, I will skip our final story. And I'll thank my collaborators, Elizabeth Hobson, who we worked together on the parakeet data she took, and we spent a lot of time thinking about it. We're almost done. I'm very excited about it. Sarah Klingenstein, Seth, and Drew, who we've worked together on, in this case, the Wikipedia data, on this case, on the Wikipedia data, and in Sarah's case, on the larger question of coarse-grained social phenomena. So thank you very much.